So see, what do you mean by solutions?
Basically, a mixture which has a solute content and a solvent content.
Yes, very good. So first of all, uh, solution is always a homogeneous mixture. Okay, a homogeneous mixture. So let's see the most important thing, that is, what is a mixture? So it is a combination of two or more substances, and therefore mixtures are of two types. The one is called as homogeneous mixtures. Okay. And second is heterogeneous mixtures. Now, homogeneous means what?
Means that the composition of the solution is the same through and through.
Yes, so you can say that you have written this.
Not sure I'm writing.
Written?
Yeah, it is done.
Nee?
Yes.
So, what do we see? We see that what is a homogeneous mixture? Now, homogeneous means what? Homogeneous means mixing of components is uniform. Okay. And in the case of heterogeneous mixture, heterogeneous means
The composition is not the
non,
same.
yes, non-uniform mixing of component. Okay. Should I rub?
Yes.
Okay. Now, next is classification of homogeneous mixture. So it is, first is colloids, and second is true solutions. Okay. So how we will classify this as uh, true solutions and colloids? Yes.
I haven't got colloids yet, but I guess true solutions would show the preferred results, while colloids would not.
Okay. See, colloids means what? In the case of colloids, what do we see that there are generally when you pass the light, it cannot make its path. Milk is a colloid, air is a colloid. So what is a colloid? Colloid means when you see that the path of light cannot penetrate, like the current scenario of Delhi, because air is all mixed up with the farm fires. The 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 smoke from the farm fire, it has totally occupied the city of Delhi, the state of Delhi, in fact. So it is becoming very difficult for the light to penetrate, for the people to breathe. Okay, so colloid it is that wherein the visibility becomes poor, and true solutions means those solutions which very easily they become a uniform, inseparable part, or a solutions or a mixtures which are totally inseparable. You cannot separate them. Okay, that is a true solutions. Now we'll start with the solutions, the definition. The solution is a mixture of two or more pure substances. Okay.
Okay.
Now there are total 9 types of solutions. Okay. Now this is very important from your board point of view. You will get an MCQ question. Should I rub?
Just 1 second.
Hmm.
Yeah, so that.
Okay. Now you make a table. Okay. Here you will write down the serial number. Here you will write down the state of solute. Here you will write down state of solvent, and here some examples. So make a good table, the number, serial number, then state of solute, then state of solvent, and examples. Okay. Now first is solid. When the solute is solid and the solvent is liquid, then what will be the type of solution formed? It will be sea water, right? Sea water has carbon dioxide, oxygen, chloride ions, sodium ions dissolved in it. Then you can say benzoic acid in benzene. Then you can take the example of sugar in water. Okay. Now second is, you continue down. I will rub after this. Solid in solid means when the solute is solid and the solvent is liquid. Then in this case, what we will see? We will see metal alloys. What are metal alloys?
Like bronze or brass.
Very good. Yes. All the metal alloys like brass, bronze, iodine, air, brass, bronze. Brass and bronze. Third is solid in gas. Now, what is solid in gas? Solid in gas is iodine in air. Okay.
Fried rice खाओगे? फेंक दो.
Fourth is, now we will see, till this part we saw the solid. Now fourth we will see the liquid. Okay. Liquid and liquid. Can you tell me example of liquid and liquid?
Liquid and liquid will be petrol or diesel or
Yes. Ethanol in water.
milk and water.
Milk and water. Then liquid, solid. Mercury is a liquid, so you can say amalgams of mercury. Written?
This I'm on the last example.
With amalgam of mercury with metals. Yani amalgaming means mixing of mercury with metals.
Oh,
Like you can say as mercury in silver. Then what is sixth one? Sixth one is liquid in gas, which is very common. You people are using.
carbonated water.
Liquid in gas. Very good. Carbonated water. Apart from that, oxygen in what? Chloroform in nitrogen. Nahin, that is different. When the solute is liquid and gas is solvent. See, always remember the proportion of solvent will always be higher. Like you take a glass of water, in that you add a you add a pinch of salt or sugar. Okay. So in this case, the constituent of gas will be very high. So like chloroform in nitrogen. Hmm?
Okay.
Now seventh is, now you tell me, gas in liquid. When we incorporate or when we put gas in liquid, then
We- Soda.
huh? Yes, can you tell?
We carbonated water only, right?
Yes,
Gas and
carbonated water. Yes. Then you can say oxygen in water. Then eighth is gas and solid. Here we are using hydrogen in palladium. Written?
writing, right?
Okay. So what is last? Last is ninth. You can say gas in gas. Can you give me an example of gas in gas?
Air.
Very good. Air contains what all gases? Oxygen, nitrogen, argon, and other gases. Hmm. Chalo. So can you revise it for me verbally?
Yeah, teacher, just 1 second. Teacher, what is given in the eighth one? The example H2 in
Palladium.
palladium. Okay. So basically, first of all, you give the definition of solution, which is a homogeneous mixture which has solute and solvent. Then after that, you gave the mixture definition, that it is a combination of elements in a defined proportion. Then you gave the types of mixture, which was the homogeneous and heterogeneous, based on whether the mixing of components is uniform or non-uniform respect. Then after that, the classification of homogeneous, colloids and true solutions, and then true solution definition you have given. And then you made me draw that table which had the solid and liquid picture at the state of solid, state of solvent, and examples. First was solid and liquid, then second was solid and solid, third was solid and gas, fourth was liquid and liquid, was liquid and solid, sixth was liquid and gas, seventh was gas and liquid, eighth is gas and solid, and ninth is gas and gas.
Yes. So basically what we see here that the solute and solvent, both of them, they combine in different proportions and we get variety of products. Okay. Now we'll see the capacity to divide. Yeah, capacity of solution to dissolve solute. See what we know actually, see here. See, basically, this is a, supposing a beaker which is containing H2. Okay. Now, if in this, supposing I am adding, first of all, some salt, then I am adding second, then I am adding third, then I am adding fourth. So what will happen? This salt will actually go and occupy the in-between spaces. All these spaces, the salt will occupy, right? So what will happen? A time will come when no more salt can be dissolved and it will settle at the bottom. So when no salt can be dissolved, this type of solution is called as saturated solution. Okay. Now how we can dissolve it? You heat it up. Heating will cause the bond breaking. So when bond will break, it will dissolve. Okay. So
Oh,
now this is what we studied right now. This is the capacity. Got it?
yes.
Okay. Now write down. Saturated solution. It is the solution which contains maximum amount of solute dissolved in a given amount of solvent at a given temperature. So when this can be given, then only we will say equilibrium is formed. Okay. So under what condition equilibrium is formed? Equilibrium will form here. Got it?
Here, sir, got it.
Hmm. So now we will see next that about the supersaturated solution. A solution containing a solution containing greater than equilibrium amount of solute is said to be supersaturated solution. So you can say that what is supersaturated solution? Supersaturated means
Means that
unstable.
it was
Yeah, unstable. Okay, unstable solution.
teacher. Could you give a few examples as
Huh? Yes.
Teacher, could you give some examples of supersaturated solution?
Yes. See, basically, that only what I told you. Ki saturated solutions means what? When the maximum amount of solute which is added, it is mixed. जैसे हम बोलेंगे कि ना बहुत मीठा पानी, बहुत मीठा, very sweet lemon water, very sweet lemonade. Okay. Now, if I say कि I am adding more salt or more sugar into it, it is not dissolving. It is at the bottom. Then we call it as a super saturated solution. And saturated means when whatever amount of solute we have added, that is dissolved. But beyond that, no dissolution will take place. It won't be soluble. Getting?
Yes, teacher, I got it.
Chalo.
Yes, teacher, done.
Now, done. So, what you will write? Solute plus solvent. First, it undergoes dissolution. Then it forms a solution. It means when it totally gets dissolved into it. Okay? When it totally gets dissolved into it, that is called as dissolution. And when it gets crystallized, when this solution can be crystallized and it gives us separate component. This is, you can see, the process which is actually taking place. Getting?
Yes, teacher, I wrote it.
Now we'll study about the solubility. So, what is solubility? The solubility of a solute is its amount per unit volume of a saturated solution at a specific temperature.
Yes, teacher. I wrote it.
Now next is, now what are the factors which are affecting the solubility? Can you tell me?
Factors affecting solubility will be the temperature, pressure, the surrounding
Yes, very good.
factors.
It depends on the, write down, nature of solute and solvent. Second, it depends upon temperature. Okay.
Oh,
It depends upon temperature. Yes. Then you can say it also depends on the pressure. Written.
yes, teacher. Better.
Now, first is nature of solute and solvent. What do we see in this? The write down first separately nature of solute and solvent. See here we see that like dissolves like. So whatever you can say, the polar solvents, they dissolve in polar solvents. And non-polar organic compounds dissolves in non-polar solvents like cholesterol in benzene.
Just once again, sir. I'm still writing.
No, no problem.
Yes, teacher, done.
Hmm. So the substances you can say, are you understanding? Any doubt in this?
No, teacher. No, teacher, no doubt.
The substances having similar intermolecular forces are likely to be soluble in each other. Written?
No, teacher, I'm still writing.
Second is effect of temperature. Neil, a bit fast, beta. A bit fast.
Yeah,
Hmm?
teacher, I'll ask on this effect of temperature.
Uh, Now, can you tell me about this?
Basically, some reactions will require heat in order to proceed as a catalyst.
Uh,
Plus, if it's a solid liquid reaction, but then the temperature is too low and the liquid freezes, then the reaction won't take place and the solution will be formed.
mm. So we'll see third. Next is, write down. In endothermic process, when temperature is increased, the solubility of substance increases. And in exothermic process, the solubility decreases with increase in temperature. For example, you can say calcium chloride in water. And last is solubility of gases. Decreases with increase in temperature.
Yes, teacher, done.
Hmm. Now, effect of pressure on solubility. So can you explain me the first two? First one, the effect of temperature. Uh, uh, Effect of temperature on solubility. What happens in this case?
Sir, only the temperature or the one before that as well?
Both the temperature and pressure. Let me see how much you know. It's a
Okay,
general knowledge.
so in the case of temperature, uh, the solubility of gases is more possible in liquids at higher temperatures because the structure of atoms becomes the same. Means there is more space between the atoms as the temperature increases.
Hmm.
Then the temperature in the temperature point, uh, solubility decreases with the increase in temperature as well.
Mhm.
Uh, that is an exothermic process.
Yes. Now,
Then
can you tell me
for,
something about pressure?
for pressure,
Yeah. What will happen to pressure? Or what effect will the pressure cause? Can you
uh,
give me an example
the
of
effect
pressure?
of the effect example of pressure. Uh,
Yeah.
the welding of two screws together
No, that
generate
is not pressure. No, we are talking about solutions. In the context of solution, how will you say? Carbonated drinks. What happens when you bring a Limca bottle, chilled Limca bottle, and you try to, you know, बोलते हैं ना उसको हिलाते हैं जोर से, and then you open. What will happen?
uh,
Fizz will come,
yes, yes, welcome.
है ना? So ये क्या
Yes,
हुआ? Because high pressure is created inside, right? So write down.
yes.
Pressure has no effect on solubilities of solid and liquid. Why? As they are incompressible. Hmm? The solubility of gases. The solubility of gases increases with increasing pressure. Now, this quantitative relationship This quantitative relationship is given by Henry's law. What is Henry's law of dilution? Written.
I'm on the Henry's law.
Okay, right. No worries.
Clear DQ.
Okay. Now write down Henry's law. What is Henry's law? Write down. It states that the solubility of a gas in a liquid, the solubility of a gas in a liquid is directly proportional to the pressure of gas over the solution. Write down S. S is solubility of the gas in mole per liter. Solubility of the gas in mole per liter. And P is what? P is pressure of the gas in bars over the solution. Done?
I'm on the P point. P is equal to pressure. Yes, yes, sir. Done.
And then you have KH. What is this? This is Henry's constant. KH is Henry's constant. You can say the proportionality constant is called Henry's law constant. Okay, so KH is equal to S upon P. S is solubility, P is pressure. That is mole per liter divided by bar. So mole per liter per bar. So we say that when P is equal to 1 bar and KH is equal to S.
Yes, teacher, done.
So we say that thus KH is the solubility of the gas in a liquid when its pressure over the solution is 1 bar. Okay.
Okay.
Now I'm giving you a numerical.
Yes.
Yeah, I'm sharing to ma'am. Ask from her. Or write down. Question write down. Calculate the solubility of gaseous oxygen in water at 293 Kelvin when the partial pressure exerted by oxygen is 1 bar. Now KH for oxygen is equal to 34840. 34840 बार पर लीटर पर मोल. करो ये. थ्री फोर एट फोर जीरो बार पर लीटर पर मोल. चलो डू ना.
लैपटॉप खोल दिया क्या?
हो रहा है नहीं.
Trying, but I haven't solved question like this before.
I put the formula na.
Yeah, sir, you put the formula, but like
1 divided by
calculate
0. बस हो गया.
1 divided by
सी हमने क्या इसके अंदर में हेनरीज लॉ का क्या है फॉर्मूला. हमने क्या पढ़ा है हेनरीज लॉ का फॉर्मूला. KH is equal to S into P, right? S क्या है solubility. तो इसके अंदर में आप P क्या बोलोगे.
okay, समझ गया. I'll do the
ओके. चलो ठीक है कर लेना. हाँ फिर देखते हैं नेक्स्ट क्लास में.
okay.
बाय.
Right.